Let's take a look at how we're going to graph this ellipse and identify the center, the vertices, the co-vertices, and the foci, or foci. First of all, I'm going to note that my equation is already in standard form. It's equal to 1. I've got everything in parentheses squared, so we're in standard form. That makes it really easy to identify certain pieces of this problem. For example, I know right away where the center of my ellipse is going to be. The center is made up of the h and k values. Those are the numbers in the parentheses with x and y. And I'm going to switch around the sign on each of those values. So my center is going to be at the point 2, -3. So let me go ahead and graph that point right away, I suppose, and get that on my graph. So 2, -3, right about there is going to be the center of my ellipse. The next thing I'm going to note in my equation is are the a squared and b squared values. Now the way I do this, the a squared value is always the bigger of the two numbers. So 36 will be a squared and 16 will be b squared. Since a squared is 36, a is just going to be 6. And b is going to be 4, the square root of each of those values. So the way I interpret those, I think of the a value as being sort of like the long radius, although that's not really a great way to say it. It's the semi-major axis, technically. The b value is going to be, I think of it as the short radius, or the technically speaking, the semi-minor axis. So basically, here's what I'm going to do with those values. I'm going to pretend it's sort of like a circle with two different length radii. Because the a value is underneath the y, and that's a vertical direction, I'm going to count up and down 6 spaces from my center. So up 6, 1, 2, 3, 4, 5, 6 will put me right about there. And also count down 6. So 1, 2, 3, 4, 5, 6 right there. So there's going to be the vertical part of my ellipse. For the short radius, or the semi-minor axis, since that came from the x part of my equation, the horizontal direction, the x direction, from the center I'm going to count only 4 spaces. That's why I think of it as the short and long radius. So 1, 2, 3, 4. And then 1, 2, 3, 4 would put me right there. So I'll do the best I can then to make a nice, neat ellipse through here. I don't know how well I will do on this screen, but I'll try. Hopefully you can do maybe a little better job of me making my ellipse. But there we go. There's the ellipse. Let's go back, though, and answer some of these other questions we didn't quite answer yet. So I've already identified where the center of my ellipse was. The vertices are going to be what's ever along the longer axis, the major axis. So the vertices are going to be in the vertical direction this time. So I'm going to label them V on my graph. And then if you count out the coordinates, I usually do this rather than try to do it in my head, I can see that my one vertex is at 2, 3. If I count this vertex down here, I can see that's at the point 2, -9. The co-vertices then are the two vertices along the minor axis, the shorter direction, whether that happens to be vertical or horizontal. So I'll label those as CV because I'm feeling lazy. So the co-vertex, one coordinate is at 6, -3. And then my other co-vertex is at the point -2, 3. And you can just count those out so you don't have to worry about trying to do this in your head visually or anything like that. Just count them out. All right, so that leaves me just one last thing to find, or two last things to find. That's the foci, or the foci, depending on how you say it, I suppose. To do this, we're going to use the formula c squared, which is c is the distance from the center to one of the foci. C squared is equal to a squared minus b squared. So that's the equation we'll be using with ellipses. So c squared is equal to a squared and b squared were those numbers up at the top. So 36 minus 16. This is why a is always bigger than b, so you don't want to subtract and get a negative value. When you subtract those, c squared is equal to 20. And if I take the square root, I'd end up with the square root of 20. Now let's go ahead and simplify that one. So here's a little review of some simplifying square roots. If I break that down to simplify, I'd have 4 and 5. I can break that down to 2 and 2. So there's my pair of 2's. Square root of 20 should simplify to 2, and then square root of 5. And so what that tells me is from the center, along the major axis, the foci are always along the major axis. So from the center, I'm going to count that many spaces above and below. So here's, obviously the problem is, well, how do you count 2 square root of 5 spaces? So here's what I'm going to look for. Let's actually go ahead and describe the two coordinates for the foci. And I'm going to do that not accurately, but exactly with square roots. And then I'll also do an approximate value as well. So my two foci are going to be located along this axis right along here. So I know no matter what, I'm always going to be counting over 2 spaces. So I'm going to start my two coordinates as 2 comma something, and then 2 comma something because I have 2 of these values. And the way that I'm going to describe this exactly without using any decimals is say, well, that center was located at -3 spaces down. So from that center, I'm then going to count up 2 square root of 5 spaces. And then I'm going to count down 2 square root of 5 spaces. So there's sort of the exact values of the foci. That's not very convenient, though, for actually plotting those points. So I think what I'll do is I'll also get a calculator out, and I'll find some approximate values here to graph those points. So if I type in my calculator -3 plus 2 times the square root of 5, I see that that value comes out to be about 1.47. Which I can plot that point fairly easily. And then I'll do the same with the second set of points. 2 comma and then -3 minus 2 square root of 5. That comes out to be about -7.47. So I can now, if I needed to, get those 2 points plotted. I'm going to count over 2 spaces because I have to be along that axis. And up 1.47, so I'd say about probably right there is going to be one of my foci. And then if I go 2 over and then down, let's see, -7 would be 3, 4, 5, 6, 7. Right, ooh, I lost count. 1, 2, 3, 4, 5, 6, 7. Right about there, -7.5 would be my other foci. So I can see that these are roughly symmetrical, and voila, after all that, there's my ellipse, there's the center, the vertices, the co-vertices, and the foci or the foci found.